Well, hello there. In the last video, we ended off a little rushed, but we are looking at this diagram, which shows the homeostatic control process that involves negative feedback. I hope that you need to really be familiar with the keywords and the key parts of this process. So beginning with the set point, and then there's a stimulus where there's a change from the norm, in this case, an increase above the norm. There's a receptor that detects the stimulus and sends that information to the control center. The control center compares the condition, the current level, to the set point. In this case, it will conclude that the condition is above the set point, and so activate a corrective mechanism. And that corrective mechanism involves target organs, involves effectors that will carry out the response. In this case, because the stimulus was that the condition increased above the norm, the response is that to decrease the condition back to the set point, right? To go back to the original state. And then there's this signal that is sent to the receptor, telling the receptor that we're back at the set point, so no need for the corrective mechanism anymore. I just want to emphasize that what you see in this loop is actually negative feedback. So if we just focus on the stimulus and the response, you'll see negative feedback very clearly. So what we're seeing is that a system, in this case your body, is responding to the stimulus, which is an increase above the norm. Here the stimulus is an increase above the norm, by giving the reverse effect of the stimulus. So the response is to reduce the condition, right? So the stimulus was an increase and the response is a decrease, the reverse effect of the stimulus, in order to restore the original state of the body and to bring it back to the set point. So you might be wondering, if there's negative feedback, is there such a thing as positive feedback? And in fact, there is. And this is a bit of extra, but I think by understanding positive feedback, you will understand negative feedback better. So we saw that negative feedback opposes change, right? So for example, if the stimulus is that if we gain weight, then I will lose weight to go back to my original weight. If I lose weight, I will gain weight to go back to my original weight. So it opposes the change. And negative feedback in that sense is a very stabilizing process. It helps to stabilize things. When it changes away from the norm, the system will react to bring it back to the norm. Now, positive feedback, on the other hand, is the opposite. So if the stimulus is that I gain weight, positive feedback will make me gain even more weight. And if something happens to make me lose weight, positive feedback will cause me to lose even more weight. So positive feedback amplifies change. And in that sense, positive feedback is destabilizing, right? It makes a system become very unstable, right? Because from gaining weight, I gain even more until like forever become super overweight and obese. Now, even though it is destabilizing, positive feedback has some uses in the body. So for example, in clotting, what happens when there's a wound is that platelets will bind and attach to the wound. And this is the stimulus, so platelets will start to attach to the wound. The response would be that more platelets, even more, will start to bind to the wound. So it's kind of like a chain effect, right? When some platelets bind first, they will secrete a chemical which attract and cause others to come and bind as well. And you can see how this is useful because we want to bind it as fast as possible. Another example of positive feedback would be in childbirth, right? And in the case of childbirth, the stimulus would be that the uterus contracts, right? So imagine the uterus is contracting and pushing this baby out. The response would be that the uterus would contract even more. So what happens is that the uterus contracts, and this stimulates the production of more of a hormone called oxytocin, which you'll learn more about later. And this hormone stimulates the uterus to contract even more, so that the baby will be pushed out as fast as possible. Alright, so the key point here is that negative feedback opposes change, but positive feedback amplifies change. But for homeostasis, the important one is negative feedback. Okay, so by now you should have some idea how homeostatic control works, that it involves negative feedback. What is negative feedback? You should know how to define that. And you should be able to state the main components of a negative feedback process, right? The set point, the stimulus, the receptor, control center, corrective mechanism, and the response. And now we're going to be moving on in the next video to look at a more detailed example of homeostatic control. Alright, so I'll see you there.